All right, we're continuing our section, Chapter 5, Section 3, dealing with trig functions of the unit circle. Right now, problem number 4, you will not see this circle on your page. One of them is I've drawn a circle. I've made a 45-degree angle, which clearly places us in the first quadrant. The cool thing about the first quadrant, everything's positive. All right? Not a lot of teenagers live in the first quadrant because everything's positive. Usually, teenagers, where do they live? They usually live in quadrant number 3, where your x values and your y values are both negative. That's where usually teenagers live. Okay? So, what we're going to do right now is we're going to find the 6 trig ratios. We're going to find the sine of 45 degrees, the cosine of 45 degrees, the tangent of 45 degrees. Moving over. Cosecant of 45. I'm not putting a little degree symbol because I just don't feel like it right now. All right. The secant of 45 and the cotangent of 45. And understand, all of these 45s mean 45 degrees. Now, Adam, the sine is the relationship between what two values in that chart that you wrote down yesterday. It's right there on your paper. Look at the top left-hand corner. Very good. The y value in relationship to the r value. Your y value is your y coordinate. Your r value is your radius. What about cosine? Tell me cosine. X over r. Good. Tangent. Y over x. Excellent. Now, the cool thing about these, Joshua, the cosecant, the secant, and the cotangent, they're just the inverses, or the reciprocals of these right here. So, not even knowing this right now, you just walked in, what's that guy do? No, cosecant. This is cosecant. Just flip them. That's it. See, look at that. R over y. Flip that. There you go. Flip that. There you go. Those right there. These are the 6 trig ratios that we're going to find for the 45-degree angle that we have. Now, whenever you guys have a 45-degree angle, I want you to think of a 45, 45, 90 right triangle, which is an isosceles right triangle, which means these legs right here have to be the exact same length. So if that's a 1, that's a 1. Okay? The special qualities of a 45, 45, 90 are 1, 1, and a radical 2. Every single time. Okay? So no matter what, a lot of times you might have seen it like this. You might have seen a teacher do a 45, 45, 90, and put x, 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 radical 2. Alright? So these are the ratios. Whatever the side is, the sides will be the same, and the hypotenuse will always be whatever the side is times radical 2. So we're just using 1, 1, and 1 radical 2 as our 3 sides of that particular right triangle. Which means, everybody, from the origin right here to this part right here, which is our x value is simply a 1. From right here going up, what's our y value also have to be? 1. So x equals 1, y equals 1, and our radius is going to equal the distance known as radical 2. So now I have x, I have y, and I have r. Once you have those 3 terms, you can simply plug them in. Let's plug them in. So here we go. I have to plug our terms in for sine. Yeah, 1 over square root of 2, 1 over radical 2. What about cosine? Oh, interesting. The sine and the cosine of a 45-degree angle are exactly the same. Tangent. 1 over 1. Of these, this one's totally done. However, something we learned the other day, Joshua, we cannot have radicals in the denominator. So since you can't have radicals in the denominator, we have to know how to rationalize the denominator. So what we're going to do, to rationalize this denominator, we're going to multiply both the numerator and the denominator by whatever is right here, which happens to be a radical 2. And our final answer for the sine of 45 is radical 2 over 2. Why is that a 2? Because radical 2 times radical 2 equals radical 4, but the square root of 4 is simply a 2. process, right? Same answer. Radical 2 over 2. All right. Now, over here, which one do you think is the easiest one to get of the three? Cosecant, the secant, or the cotangent? Which one do you think would be the fastest? Cotangent, heck yeah, because we have 1 over 1, which makes this what? 1 over 1, which is simply just a 1. And you're done. Now, Adam, this is where students sometimes do too much work. For the secant of 45, they put r over x, and they look at their final answer, and they do 2 over radical 2, and then they have to do what again? They have to go back and rationalize. Don't do that. Don't do this. Don't look at your final answer here. Look at your beginning one right here. What is your radius? Your radius was a radical 2. What was your x value? 1. So what's radical 2 divided by 1? Simply a radical 2. You're done. R over y. Look, what's r? Radical 2. What's y? 1. This is also simply a radical 2. 1, 2, 3, 4, 5, 6. Those are the 6 trig ratios for a 45-degree angle. Feel free, after you put that into your journal, feel free to transfer it over to your assignment. All right, we're going to go and do problem number 6 as well. It says find the values of the 6 trig functions for angle theta in standard position if a point within the given coordinates lie on its terminal side. Now that says a whole bunch. Let me go ahead and just kind of draw out what this is saying. Let's say I have an x-axis and a y-axis right here. In fact, you know what I'm going to do? I'm going to go to graph grid paper so you guys can see it a little bit clearer. So here we go. Adam, what was the coordinate? Was it at -1, +5? Is that correct? -1, +5. This is problem number 6. This is our x coordinate. This is our y coordinate. So automatically, you know what your x value is equal to. It's a -1. And you know what your y value is equal to. It's a +5. We go over -1 and up 1, 2, 3, 4, 5. We put a point right here. Label that -1, 5. What it's saying is if you have, let's say this was your circle, and your initial side was right in here. There's your initial side. Your terminal side, change colors. Terminal side is going to be right there. So let me explain to you what theta is. Theta is the angle that's created from your initial side to your terminal side. So that's theta right there. This right triangle that I'm about to create is going to be a really, really, really small sliver of a triangle. From here, I'm going to go straight down, right there. It's kind of hard to see. I'm going to shade it in green. I'm going to have to use a really small highlighter. All right. You guys see that little tiny sliver of a triangle right there? Okay. So, understand, this terminal side represents your radius. Here's a formula that you're going to need. Okay? You need to know that your x-coordinate squared plus your y-coordinate squared will always equal your radius squared. What is our x-coordinate? -1. We square it, we get +1. What's your y-coordinate? 5. Square it, we get 25. So what is our radius squared equal to? Our radius squared is 26. Well, what does that make our radius? What do we have to do to solve for r? We have to take the square root of both sides. So our radius is actually radical 26, and you're going to leave it as radical 26. So put r is equal to radical 26. So now you have what? You have x, you have y, and you have r. You have all three that you need to finish the 6 trig ratios. Okay? With all 3. So right now I'm going to go back. Okay, it's right here. This is the picture to go with it. I'm going to go back. And now I'm going to erase this. We don't need it. Okay? I'm going to relabel x equals what? -1. Y is 5. R is radical 26. By the way, the radius will always be positive. You'll never have a negative radius. Okay? So if you see a negative sign, that never applies to the radius. It either applies to the x coordinate or the y coordinate. Here we go. Right? Sine of theta. Cosine of theta. Tangent of theta. Sine, cosine, tangent. We're going to start with the basic 3. Y over r, x over r, y over x. We're going to start with the 3. Adam, do the first one. Joshua, do the second one. And I'll do the third one. All right, Adam, go. Over r. Radical 26. Can I keep it like that? No, I can't. So what do I have to do to the numerator and the denominator? Radical 26 over radical 26. Now, what do we get when we do that? What's your final answer? That's it. 5 radical 26 over 26. And you're done. That's the final answer because the radical is in the room. All right. Joshua, do the next one. Can I keep it like that? Now, your answer is correct, but you don't have to put a -1 in front. You can just make it a negative radical. That's your answer there. And yes, I saved the last one for me because it's simply 5 over a -1, which is a -5. So I gave myself the E. All right, so here we go. Now we have cosecant of theta, secant of theta, and the cotangent of theta. R over y, r over x, x over y. All right. So Adam, I want you to do the r value over the y value. What is the r value over the y value? Radical 26 over 5. Am I done? Yes, because the radicals are already in the numerator. Joshua, next one. And so what does that end up becoming? You got it. Negative radical 26. Here, we're going to put -1 over 5, which is simply a -1 thing. There's your 6 trig ratios for problem number 6. What I'd like you to do, 2, 7, and 8 the exact same way. You don't have to make a picture, but what do you need to find? You need to find these 3 pieces. You need your x coordinate, your y coordinate, and you need to know your radius. And what's the formula to find your radius? X squared plus y squared equals r squared. Okay? Finish that up, and you will be able to get a great grade.